Hi folks. So in this video I want to talk about convergence of series, and here I'll try to give you an intuitive way of telling if a series is convergent or not by looking at it. You still have to go through the tests and make sure that your intuition is correct, as well as you still need to know how to prove it. So we'll also talk about different methods that will be applicable in various cases. So um, let's look at, for example, ln of n. So this grows a little bit slower than n itself. Now, so both of them grow pretty slowly. Slowly meaning I'm not talking about speed, but as far as the convergence goes, so if we know that 1 over n series with 1 over n, which is a harmonic series, does not converge, and same with 1 over ln of n. So neither of them converges. So let's put these two in one category, and so what trumps this? You have now we have n to the power of k, where k is greater than 1. So this grows pretty fast. So that is things like n square or n to the power of 5. If you have a series, for example, um, sigma 1 over n square, that would converge, because n to the power of k, when k is greater than 1, so grows pretty fast. And something that grows even faster is a to the power of n, when a is greater than 1. Of course, when a is less than 1, a to the power of n, as n goes to infinity, just goes to 0. So, but if the comparison is between n to the power of k and a to the power of n, a to the power of n grows faster. And the thing that grows even faster is n factorial. So why do we care about this? So that is, if you are given a problem that has something like, let's say, n to the power of 10 divided by 3 to the power of n, when asked does this converge or diverge, it's not that obvious, because n gets pretty big, 3 to the power of n gets pretty big. But if you think of this rule where a to the power of n, in fact you can also take any number and see that these relationships do in fact hold. I'm not just making them up. But so 3 to the power of n is of this form, a to the power of n, whereas n to the power of k, if for a specific value, it could be n to the power of 10. So now this grows slower than 3 to the power of n. So you would automatically assume that this possibly converges, because 3 to the power of n is growing faster. So how can you prove that this in fact converges? You can use the ratio test, and you will find out that it in fact does converge. Now what's the other, let's make up a few more problems. I think I have a couple of them. So the other one is, if somebody asks you n factorial over 2 to the power of n. So n factorial grows pretty fast. So you can again do the ratio test. You'll find out that this in fact diverges. And this, we said, converges. So let's maybe just to make it clear, let me show you what happens here in this particular case. You have sigma n to the power of 10 divided by 3 to the power of n. Okay, So our ratio test would be, what does it say? You take the next term of n plus 1 and take the ratio between that, which would be n plus 1 to the power of 10 divided by 3 to the power of n plus 1. You take then this term and we divide n to the power of 10 divided by 3 to the power of n. If this ratio is greater than 1, then the series is going to diverge. If it is less than 1, it converges. So, and if it's equal to 1, it's not conclusive. So in this case, you would have n plus 1 to the power of 10 divided by n to the power of 10, 3 to the power of n divided by 3 to the power of n plus 1. So here 3 to the power of n, 3 to the power of n you can cancel out. So you would be left with n plus 1 to the power of 10 divided by n to the power of 10 times 3. So the limit of this first part, you could figure this out. This would be, even intuitively you can see that as n gets larger, 1 is not very significant. So this becomes 1. So our limit of this ratio is going to be just 3. So since that is greater than 1, this is going to diverge. So let me give you a few problems. So I'll come back to that relationship. So again, let's look at this relationship. So n to the power of k grows much faster. A to the power of n grows even faster. N factorial grows even faster. To the extent that they do, if we take ratios, they do impact the limits.